So in this video, we're going to begin looking at our first non-right triangle rule. If you would go ahead and complete problem 1 and 2 through D and then stop, and then turn the video back on, I would recommend as you're working through this to work with a partner. You might find that working in groups of 2 and having conversation might be helpful in terms of being able to come up with answers as you collaborate. Again, when you're finished, turn the video back on. All right, so in this problem, let's using sine angle A. So the sign for this would be opposite over hypotenuse, so hopefully you chose A over C. For angle B, the cosine would be the adjacent over hypotenuse, which is also A over C. And then the tangent, going back to the first angle, would be A over B. Just kind of comment about these two answers. The reason why they are the same, because as we talked about, the sine of one angle and the cosine of the second angle will have the same angle as long as, same answer as long as angles A or B add up to 90 degrees. And this is the reason why you get the same answer, because they are representing the same ratio in the right triangle. All right, so the first one we're looking at angle B and A, and we're trying to get side X. So this problem here would be a sine problem. So sine of angle B is equal to opposite over hypotenuse, and if you cross multiply, A times sine of B is equal to X. In the second problem, B, you're looking for X using angle A and side B, and this also would be a sine problem. Sine of angle A is equal to X over B. And then if you would cross multiply, you would get B times the sine of A is equal to X. So what can you conclude about your answers to A and B? Hopefully you concluded that the answer to A times sine of B and B times the sine of A are going to be the same answer because they're both equal to the same X value, the same height or altitude of that triangle. So hopefully you stated this in some way. And then problem D says, show how your answer in C, which these two things are equal to each other, they both equal X, leads us to the answer below. So when this rule was being developed, mathematicians decided to turn this problem back into a proportion. And the reason why they did that is because they wanted to make sure that students lined up the correct information in the ratios. So by dividing both sides by AB, A divided by A would be canceled out. That would be a value of 1. And the other one, B divided by B, would be canceled out, again having a value of 1. And what would be left would be the sine of B over B, and the sine of A over A would be equal to each other. And that's the answer for D. So again, by doing this division by AB, what we're doing is we're basically lining up the angle and the side that's opposite the angle. So in geometry, we use the same letter, capital letter for an angle, lowercase letter for a side, and we always put the side name opposite the angle using the lowercase letter of the angle. So that's critical in terms of making sure you set the problem correctly. So in problem E, do you believe that sine of C over C will have the same answer as sine of A over A and sine of B over B? So what I did was I redrew the triangle that you had in the top part of the problem 2, and I moved C and B around to show you that how does this compare to, if I set this one up as find our side X again, how does the ratios look this time. So if you're not sure, go ahead and set the problem up using the same steps, except instead of using angle B here, we're using angle C. Instead of side B, we're using side C. And then take a look and see what the answer would have been looking like here. And then turn the video back on when you were finished. So if you would have done this side over here, you would have got the sine of C is equal to x over A. So cross multiply. So x is going to equal A times the sine of C. And if you'd done this side here, you would have had the sine of angle A is equal to x over sine C. And then again, if you cross multiply, C times sine of A is equal to x. So that means that A times the sine of C and C times the sine of A are going to both be equal to each other because they both equal x. And again, using the approach that mathematicians decided to use to get rid of the A's and the C's, what we end up with is the sine of C over C and the sine of A over A. Over A is going to be the same answer. Very similar to what we did earlier. So will sine of C over C have the same answer as A? And the answer is yes. If we just reposition the sides so that the letter here, for example, is C, and the original problem being B, the second problem, I think if I would do the same thing here, make these A's, for example, take the A's and turn them into side B and angle B, and go through the same steps again, I would end up showing that side C over C and sine A over A would have the same answer as well. So to finish off the bottom of page 1, for any triangle, and that includes right triangles, ABC, it is always true that the ratio of the sine of angle A and its opposite side A, sine of angle B, its opposite side B, and sine of angle C, over its opposite side C, that those ratios will always have the same answer. And this is called the law of sines. So again, the reason we call it law of sines is because back in the previous problem, we used sine each time to solve problems. So this is the sine rule. So we're going to take a look at problem 3. We're going to do this one in class. And this one does not have a height because we don't need the height. What we need to understand is that the sine of some angle, which we'll call A, over its opposite side is going to be equal to sine of some angle over its opposite sides. Whether the letters are A, B, C, X, Y, Z, it doesn't matter. The key here is we are always pairing up the side with and the angle that's opposite each other. So in this problem here, for example, this angle here and this side here are considered opposites of each other. And this side here and this angle here are considered opposites. And this side here and this angle here are also opposites. So the one thing you have to be aware of is that in solving this problem as a proportion, you have to have 3 numbers. So 2 sides and an angle, 2 angles and a side, but you have to have 3 of the 4 numbers so that when you cross multiply to solve for the missing value, you can do that. So if you look at this problem, side X is missing, so that means this pair X and 40 is not complete. The 60 and the Y, again, not complete. And the 10 and the angle are not complete because you don't have both numbers. So sometimes in geometry you have to go one step further and look for that missing information. And what we can actually figure out here is that third angle. So since the sum of the angles of the triangle is 180 and we have 2 of them, that means the third angle has to be 80 degrees. And now we have a complete pair. So whenever I set up a law of sines problem, I always begin with the completed pair side angle that are opposite each other. So sine of 80 over its opposite side is equal to the sine of, again, an angle. So let's say, for example, we're going to solve for x this time. So I'm going to pair it up with 40. So sine of 40 over its opposite side, x. If you wanted to solve for y, go ahead and set the proportion. That would help us solve for y, and then turn the video back on. Again, have a conversation with a partner and see if you guys are in agreement with what the proportion would look like. And then again, turn the video back on when you're ready to continue. So hopefully you continue with the sign of 80 over 10 because, again, you have both numbers. So I always suggest if you're doing multiple problems that you start with the first ratio should be the one in which you have both the angle and opposite side. So to solve for y, I'll be using the 60-degree angle with the side length of y. So make sure the sine is always being paired up with the angle. Sometimes students will pair up the angle measure or sine with a side length and not an angle. And then from here we're going to cross multiply. So to cross multiply here, we have x times the sine of 80 degrees is equal to 10 times the sine of 40 degrees. It's really important here as you work these problems that you can have it put in parentheses, especially in your calculator, because if you don't close the parentheses, especially on the angle measurements, you will probably end up with a different answer that's not correct. Now, because we're solving for x, we need to get rid of the sine of 80 degrees on the left side, so which is the value of 1 we divide by it. And again, we need to do the same thing on the other side. So the value of x will be 10 times the sine of 40, again, close that parenthesis on the 40, divided by the sine of 80 degrees. So the length is approximately 6.527. If you go ahead and complete y, value of y, turn the video back on when you're ready to continue. And this will be the last problem for this video. The rest of the work that I will be doing for this handout will be in the next video. Alright, so again, like the first one, we're going to cross multiply. So hopefully you paired up the y with the sine of 80 degrees, 10 times the sine of 60 degrees. We need to divide by the sine of 80. So I get the value of y by itself. So this is the problem we're entering in the calculator. Get the approximation. So 10 times the sine of 60 degrees divided by the sine of 80 degrees. Hopefully you ended up with 8.794. So, all right. So go ahead and close this video out, and then click on video 2 for this lesson. Continue with problem number 4.